Hey, that's the
All
whole
right.
issue
Hi,
of that.
Robert. I just want to say hello.
Hello.
And I have one of your telescopes.
Okay.
Signed. It is, I've named it Cole, and it's living outside in one of the observatories.
Oh, you didn't name it after me?
No, I named it after Cole of Spyglass Mountain, which was my dad's favorite.
Okay. Well,
Welcome to Tucson International Airport. This is Mayor Zulema. Thank you for coming for you. Hope you enjoy the visit. If you look at the parking,
if somebody's speaking, I cannot understand them.
Uh, David Levy's at the airport. And
Oh,
that's the PA.
very,
Oh.
very poor connection.
Yeah. Well,
Yeah.
it's
Picking up background.
far away from the PA, so
Yeah.
that's
Yeah,
not
it-
someone trying to talk to us.
Yeah, it sounds like it's bouncing in an echo chamber.
It is bouncing in an echo chamber.
Scott, if you want to go ahead and start, I think
Can we
we
go
can
get
probably go
started?
ahead and start.
All right.
Okay.
Okay. Well, everybody, thank you for tuning in. This is the Astronomical League live program, and I'm Scott Roberts from the Explore Scientific and Explore Alliance, and we're happy to have you here tonight. And I'll let Terry Mann take it away after our intros here in our little feature video.
Roughly every year or two, somewhere in the world, the sun appears for a few moments as a ring of fire in the sky. This is called an annular solar eclipse. Annular comes from the Latin word annulus, which means ring. An annular solar eclipse occurs when a new moon passes directly in front of the sun but appears too small to cover it completely. But why is that? It's because the moon's orbit around Earth isn't a perfect circle, but rather an ellipse, or slightly oval-shaped. This causes the moon to move closer to us and then farther away during its month-long orbit. When the moon is at its closest point, called perigee, it appears slightly larger in our sky. When it's farthest from us, at apogee, it appears a little smaller. But we don't see an annular eclipse every month. That's because the moon's orbit is also slightly tilted in relation to Earth's orbit around the sun. This means during most months, the moon is either too high or too low to block the sun. So only when a new moon is at apogee and passes directly between Earth and the sun, do spectators on Earth get the rare opportunity to see the ring of fire in the sky. Unlike a total solar eclipse, when the moon completely covers the sun, during an annular eclipse, the sun never fully disappears. So if you're lucky enough to be in the path of an annular solar eclipse, make sure to wear your solar eclipse glasses or use other safe solar filters to witness this spectacular ring of fire in the sky.
Hello, everyone. This is Scott Roberts again from Explore Scientific and the Explore Alliance, and it's my great pleasure to introduce Terry Mann, the host of Astronomical League Live. Terry, you want to come on? You are muted.
Let me start again. Thank you, Scott. We're all happy to be here, and thank you, Carol, David, and Robert. Appreciate all of you being here tonight to be on AL Live. So I hope everybody's going to have a great weekend. It looks good here in Ohio. Hopefully it's going to be great everywhere else. So what I would like to do is David has taken the time to join us. He is at the airport. So I'd like to get David Levy on as fast as possible before his plane leaves. So David.
Thank you so much, Terry. And I'm so much looking forward to the happy Astronomical League Alcon coming up next summer in Kansas City. I'm on my way to Albuquerque for my granddaughter's wedding, but it's the same day as a very sad and tragic anniversary for me. It is 1 year since Wendy died last year. And so for my poem, I'm going to read the one that I wrote recently during a particularly bad day, called Wendy Amongst the Stars. Here goes. Each day I awake. Today is the day. I look towards her. She is not there. My heart goes on, but do I care? Well, anything let in a ray. The night is dark as coal. The sky is stars from west to east, from south to north, just like a feast, a pill, heaven sent to calm my soul. A telescope stands and waits for my eye. It asks just one brief look, forward through space like an open book, and backward through time, open wide its gate. I see a star. Why is it there? Lapis philosophorum, philosopher's stone that strikes the night. It ushers me home as part of a pattern to learn. I dare, but reason not. General relativity, gravity's geometry, no speck of thought, no idea works, no system bought, a newborn thought of creativity. And the final verse, Wendy, she's a part of me, a beam of light amongst the stars in the sky, a star, not there, but there, her soul so far, from grief to joy, all through the night. Thank you very much, and back to you, Terry.
Thank you so much for being here, David. That's beautiful. And we'll all think of Wendy. She was a great lady, and we'll all give her a great thought tonight, as we do a lot of times. You guys crossed my mind quite a few times. So thank you so much. You have safe travels. Have a fun time at the wedding. And we hope to see you soon, probably next month too.
Yeah,
So,
I definitely. Yeah.
Yep. Yeah, which reminds me, while I'm talking about that and you were on here, we're going to have another Halloween party next month. So it will be on October 27th for AL Live. Some people will probably be dressed up and others will probably look normal, but we're going to have about 5 to 6 different speakers that will be giving very short talks. And just please join us on October 27th at 7 p.m. EDT. And get ready for a fun night. So enough of that. Yes, you will definitely be there too, I hope. That's why I thought I would give you a heads up. Carol, how about if we go to you and you can kind of give us an update on everything that's going on in the league and anything else that you'd like to go into?
Thank you, Terry and David. Thank you for being on here. Safe travels as you go to your wedding. Quite a bit going on with the league. We're putting Baton Rouge to rest, and we're turning the page and looking toward Alcon 2024. And I'm going to share my screen.
No, it's here.
Perfect.
Hey, everybody see it?
Yep.
This is our conveners in Kansas City decided to go with the jazz theme. That's part of what Kansas City is very famous for. And you'll look at the upper left hand, you'll also see the symbol for the Kansas City Chiefs, which is another reason we're in some quarters, if you're a sports fan, fairly popular right now. I won't talk about the logo to the right of the Kansas City Chiefs, because we are having a few problems with the baseball team, but we won't talk too much more about that. So the dates have been set for Alcon 2024, July 17th, which is the Wednesday, and through Saturday night, July 20th. We anticipate having a wonderful meeting, and I'll go to the next slide to talk a little bit more about that. We will be at Linda Hall Library, which is a science and engineering technology type library. It's world famous among the science group across the world. And it's an opportunity, and we're going to be in the rare book room. We'll have a display showing all kinds of first editions of astronomy books. And it's an opportunity to actually hold those books, many of which are first editions. And they are very generous with their time to let us look at those. So that's something to look forward to. And we'll be having probably a reception at Linda Hall. And then I want to go to the next slide. Just so happens that somebody who's on this talk tonight David Levy, back just a few years ago, donated his observing logs to Linda Hall Library. And in addition to having all the logs that he has used over the years during his famous years of comet hunting and also other astronomical observing, he also donated his first telescope ever to Linda Hall Library.
That's cool.
And we just may be able to pull off getting all that together in an exhibition. I'm pretty sure we can. David could probably swing that for us, I would think. And here's the board of directors of Linda Hall just a few years ago. That was a ceremony where David officially presented that display to the care of the Linda Hall Library. Now it's going to be a wonderful experience. We have other field trips planned as well. There's other locations for non-astronomer types, including the World War I Museum and other things we'll be talking about other than that. It'll be held in the Kansas City area. We will announce the exact location within about the next week to 10 days. And I think that is it for a thumbnail sketch of what Alcon 2024 is going to be all about. And now, Terry, back to you.
When do you think you'll have the website online? Any registration or? Yeah.
Registration, of course, the goal is always the first of the year, but we would like to have it there by November 1st.
Okay.
That's the goal, because we want to really, this will probably be a hybrid convention. We've had many of our past attendees really ask if we could have a hybrid convention, both online as well as in person. And we're going to try to respond to that desire in 2024.
Yeah. Yep, that will be interesting. Scott did so many cool interviews at Albuquerque. I mean, so many people watched the interviews. It was, it's a lot of fun to see him interviewing the youth and everybody else that's there.
Yes, it is. That's a big part of it. And there's people watching those all over the world, and it's really a good situation. So we're really looking forward to that again, Scott. Now, I have a feeling, since it's a little bit closer than normal, Scott could probably be persuaded to come up north a few miles.
Oh, yeah. Yeah, I'll be.
Thank you, Scott, for all you do.
Yeah. Scott, how far is that from you? That's not real far, is it?
Oh, I think
I'm going to say 250 miles or something.
6-hour drive.
Yeah, it's about an 8-hour drive for me. So I'm planning on driving too. So are we going to be going out to the observatory?
Yes, we will. Powell Observatory will be the side of the Friday night so-called Starbecue.
Oh, we're starbecuing there again.
Yes.
So, but the actual conference itself, the daily conference, the talks and stuff will be where?
That cannot be announced just quite yet, but let's just say we are probably signing the agreement next week.
Okay. All right.
That's why I said in the Kansas City area. It's the immediate area.
Okay. All right.
So that means League Sales will have a big display there too, since we'll be right in the backyard of the office.
And I hear rumors that there's going to be lots of international type speakers at that event on good authority. I think I've heard that right. Correct, Terry?
Yep, I think so. From what I keep hearing.
Yeah, but we're really looking forward to it. The Astronomical Society of Kansas City is 100% behind this, and it's going to be a great convention.
Yeah, we've actually got a few years of really amazing Alcons coming up, people that have stepped forward that would like to host. Don't forget, in 2025, after Kansas City, we'll be going to Bryce Canyon.
Yay.
Yeah, I know. That will be fun too. Yeah, I mean, Kansas City, when we were there the last time, was fantastic. I enjoyed it so much. So I think that will be an amazing time. There is so much there to see and do.
Absolutely.
So
try to be good hosts on it all.
yes, well, you do a great job on that. So that is really nice. What we will do here shortly is head to our keynote, but I was trying to think. I had a fun experience this week. I was able to stand on top of the Mackinac City, the Big Mac Bridge up at Mackinac City. I did a bridge tour and got to stand on the South Tower. And it's something that I'd seen an article on and was fortunate enough to get a certificate to do that. and it was amazing. I thought for sure I'd be ready. I didn't know what I was going to do being up that high, but it was really beautiful. So that was fun. And now what I would like to do is talk to Robert Reeves. It has been so long since I have seen you. I believe the Winter Star Party quite a while back.
Oh gosh, that
Uh,
would have been 2006 because that's the last time I was able to be at the Winter Star Party.
yeah, maybe I saw you at NEAF pass by. Were you at NEAF this year?
Oh yes.
Yeah, I think I saw you at NEAF, come to think of it, somewhere when I was going down one of the aisles. I saw you speaking with somebody.
Yeah, I
So it
was
seems
with
like,
the Celestron group, and I was also one of the NEAF Talk speaker this year. So,
ah,
I had my thumb in NEAF this year as well.
yeah, that sounds great. Yeah, I was able to go to NEAF with the league this year, so that was pretty nice. We plan on being back there next year. So that's a great way to see all of the new stuff that's becoming available and meet people that you've always wanted to meet. So NEAF is a
Exactly.
lot of fun. Yes. So you have a new book coming out, or that has just came out, that I'll let you talk about. But I look forward to hearing more about that. And what I would like to do is tell you a little bit about Robert, just in case you don't know him, but I can't imagine not knowing who Robert Reeves is. So, Robert has been exploring the cosmos since 1958 and took his first lunar photograph in 1959. He began telescopic astronomy with a 4-inch criterion dynoscope, his Christmas present in 1960. In 1975, he acquired a Celestron C8 or Celestron 8 telescope, which he still uses today. Today, he also uses a Celestron 11 Edge HD and a Skywatcher 180 Max 2. I never can say that right. Max, yeah, Max 2. There we go. For lunar photography and his from his Perspective Observatory located in Central Texas. Robert also uses a Skywatcher 20-inch Stargate telescope for visual observation and a 14-inch Celestron with a hyperstar for deep sky photography. I would like to have your observatory. It sounds amazing.
Yeah, it's a lot of fun.
I bet. In 1984, Reeves published articles about astrophotography in Astronomy magazine. Since then, Robert has published over 250 magazine articles and 250 newspaper columns about astronomy, not to mention the books. Robert Reeves is an accomplished deep sky astrophotographer. His current passion is repopularizing the moon within the amateur astronomy community by explaining the origins of the moon, evolution of its face, and introducing its geology to moon lovers everywhere. For many years, Robert has published different lunar photos with descriptive text in his daily posting called 365 Days of the Moon. Today, Robert continues his tradition with daily postcards from the moon, highlighting a different feature of the lunar face every day, which we all, I mean, that's amazing. So many of us talk about the moon interfering with what we do, but yet at the same time, it is so beautiful to watch a moon rise and just sometimes just to sit back at night and look at that beautiful moon in the sky. So, Robert, thank you for being here. Thank you for speaking. And I am looking forward to your talk.
Thank you for that wonderful introduction. I deeply regret that circumstances didn't allow me to be at Alcon to present in person like I was supposed to, but circumstances worked out that my wife needed urgent surgery on the very day that I was supposed to speak. And in an incredible coincidence, here I am. I'm able finally to deliver this presentation to the Astronomical League. And what do you know? Yesterday, Mary had follow-up surgery as well. So I think the trick here is to keep Mary out of the operating room is to stop trying to present to the Astronomical League.
Got to be a better way.
Yeah, I know it's just a coincidence, but Mary's doing well. This time the
Good.
surgery went very well. It was not as obtrusive as before. In fact, she went shopping today on her own and is getting around just fine. So I'm pleased that that worked out well. And in addition, I'm able to catch up and talk to the Astronomical League about the moon. Because, as you said, it is kind of my passion. I love doing deep sky astrophotography. Um, I do it from the middle of San Antonio, Texas. The filters that are available today allow me to do better deep sky astrophotography from my own backyard in the center of San Antonio than I used to do by going 100 miles out of town or to the Texas Star Party. So it's a whole different smoke nowadays. And both deep sky and the moon are my nighttime companions.
That's great. That's great. And I'm glad to hear your wife is doing so well too. Yeah, I could not believe when you emailed me and said, "You're not going to believe this, but my wife has to have surgery on Thursday." I thought, oh no.
Yeah, it seems to follow Astronomical League appearances, doesn't it? Well,
We'll break that.
yeah, that cycle will be over with next time I'm with you all.
That sounds great. Well, we're glad to have you tonight. So we will go ahead and let you get started.
Okay, let's go back to my screen share and see if this works like it should. And
Yes.
Yep.
you are screen sharing.
Yep.
Okay. Except it's not advancing, and I don't see that. Oh, the arrows, that's what I was supposed to use. Okay, I think we've got this down. Yeah, this has been a interesting trip getting screen share to work. Sometimes it works beautifully. Like I said, I gave this presentation to a group in England about 2 weeks ago, and it was flawless. And today we've had to do jump through flaming hoops of fire to get it to work, but I think we got it going. So Terry mentioned that I just came out with a new book about the moon. It's called Exploring the Moon with Robert Reeves, a very pretentious title, but deliberately said so with my name to differentiate it from the other books out there also called Exploring the Moon. So if you've enjoyed my postcards from the moon, my previous 365 Days of the Moon series that I've done since I think 2014. It's been forever that I've been doing this. Then I think you will enjoy the book I just came out with. It is. I've been observing the moon for over 60 years. I have tons of moon books, and I presented the moon in this book the way I think it should be presented to the amateur astronomer who wants to ramp up their knowledge of the moon, understand the moon, and become friends with the moon. The moon is not an object to be avoided because it interferes with the deep sky, but an object to be embraced when it's there as an alternative target. And once you understand the moon and become friends with it, there's much to see on the moon, as we will see during our presentation tonight. So let me launch into it. And the arrow buttons are not working. Uh-oh. Scott, help.
Okay.
It's not advancing the slide.
It's not advancing the slide, huh?
Okay, let me get, oh, suddenly it did. I didn't do anything. Maybe there's a huge delay.
Just took some time. That's all.
Yeah, it took like 10 seconds. Anyway, my presentation, Postcards from the Moon, a play on the stuff I'm doing nowadays, posting. It's actually turning out to be about every other day post on Facebook where I detail a target on the moon. And yes, it's working now. Okay, so starting off, in the half century since Apollo, much has appeared in the media about how we got to the moon, the politics of why we went to the moon, and the personalities that engineered, directed, and actually flew the Apollo missions to the moon. One thing that I'm very proud of is my book came out last month, and one person who may be going to the moon has a copy, and one person who actually went to the moon has a copy. So I'm very proud of that. So there we go. But in the half century since humans last set foot on the moon, how much does the average person actually know about the moon? Well, the answer is surprisingly little. We've been trying to avoid the moon instead of look at it. So I'm going to try and fix that. So I've been in love with the moon my entire life. My earliest memories of the moon were watching moonrise through my bedroom window when I was a child. And today, the space age explorations have not stripped the wonder and the mystery that I felt for the moon when I was young. There is a name for people like me, and it is not lunatic. It is selenophile, a person who loves the moon. And I hope when I'm through here, you may also become a selenophile, somebody who loves and understands the moon a little bit more. So, a little background about me, as Terry mentioned, in 2000, I published the book Wide Field Astrophotography. It was well received, but photo technology changed almost immediately after it came out, and it was the last book published about film-based astrophotography. So in 2005, I published the book Introduction to Digital Astrophotography. This was the first book written about astrophotography with a DSLR camera. Although I'm well known for my lunar photography, I also enjoy urban deep sky astrophotography with my Celestron 14 and a Hyperstar 14. Hyperstar. These images were taken from my backyard here in San Antonio, in the middle of a city of 2 million people. The moon does not interfere with this photography. I can take pictures, these deep sky images, with a full moon within 30 degrees of my target. So we no longer consider the moon an obstacle. The moon is a companion. It is an alternate target. So let's learn a little bit more about this. Continuing on, in 2006, I published Introduction to Webcam Astrophotography, and I like to think that this book helped popularize the webcam video capture for planetary photography. I'd like to think it launched today's planetary camera industry. Now, my moon photographs have appeared on the cover of magazines and have appeared in magazine articles, some of which I wrote. They've appeared on the covers of science fiction books, as well as technical publications. And if you have the Backyard Astronomer's Guide, the very popular Dickinson and Dyer book, all the fourth edition, all the moon pictures in them are mine. Now, over the past 20 years, I've spent a large amount of time chasing big telescopes across the southern United States in an effort to take high-resolution lunar photographs. But I find I can take better images of the moon from my own observatory at home with 7 to 11-inch telescopes. And why is that? Well, the poor seeing does not degrade the image in smaller telescopes as much as it does in larger telescopes. The average seeing cell, the ball of moving air in the air that is making stars twinkle and making lunar and planetary images shimmer, is basically about 7-10 inches in diameter. With a small telescope, you're looking through one of those. With a large telescope, you're looking through many of them, and they combine and degrade the image worse if the seeing is very poor. Of course, if you're on top of Mauna Kea or on the Canary Islands, the big telescope will work well. But if you're down amongst the rest of the world like we are, well, the smaller telescope actually works better on the moon. So how good is modern lunar imaging with a modest telescope? The image on the right is a plate from the famous Kuiper Lunar Atlas. It was the best the professional astronomers could do from the Earth in the 1960s. The image on the left is taken from my backyard with a Celestron 11 telescope. I'll let you be the judge as to which one is best. I like to say that I have no special talent. I'm not a trained astronomer. I have no degree in it. I'm only passionately curious. I'm exactly like you. I followed my curiosity and I learned as I went. Anything that I have done, everybody else is capable of doing. I did it on my own, figured it out myself, and I have a trail of books behind me to help you do the same thing. So I like to say the moon is my playground, and I would like to invite you to come out and play with me. So when I was young, the moon was a big deal. This was back in the 1960s. The moon was a dream. It was a goal, a destination, a place of mystery to be explored by brave heroes who dared set foot on another world. Then in the mid-1970s, there was a fundamental shift in amateur astronomy. The introduction of the 8-inch Schmidt-Cassegrain gave us a powerful, affordable, and portable telescope that opened up the deep sky to amateurs. No longer did we have to drag around these huge, clunky Newtonians. These SCTs were very portable. We could get out of Dodge and enjoy the deep sky, and the moon faded from our dreams. But my goal in this presentation is twofold: to bring the moon back within our astronomical realm, and to make it not something to be avoided because it interferes with the deep sky, but to get you not to just look at the moon, but to see it and understand it. Today, many astronomers consider the moon boring, a place covered with bumps and holes. But the moon is not visually static. It is a geologic wonderground that changes day by day, even hour by hour. There is much to see on the moon if you know what to look for. And I want you to go back with me to the moon and rediscover its wonders. So tonight we're going to look at the creation of the moon, the evolution of the moon's face, understand the various forms of lunar geology, and explore some of the sentimental lunar favorites that are repeat targets for both newcomers and old seasoned lunar observers like myself. So the first event that happened on the moon was necessarily the creation of the moon. There are many theories about how the moon came about, but the most popular and still controversial is the idea that the moon was created by the collision of a small Mars-sized body with the proto-Earth not long after the solar system was formed. This intruder world, we theoretically or hypothetically call it Theia, T-H-E-A-A. And like I said, the theory is still controversial, but it holds the most weight to solve all of the issues of how the moon came into being. So we call this the giant impact theory, of course. And there's been numerous computer simulations, the most famous, of course, by Robin Kent up at Southwest Research up in Boulder, Colorado, that established that after the collision between Theia and the moon and the proto-Earth, the moon started forming within a day or so. And after a year or so, had accreted pretty much into the state that it's in nowadays, size-wise. Now, an early molten moon looked very different than today's moon. The iron and heavy radioactive elements sank to the core. Silicates floated to the top in a global magma ocean, and it took millions of years for it to solidify. Now, the science fiction vision of a glowing ball of molten rock flying through space sounds very good, very Star Trek-ish, but in actuality, our molten moon was probably a very dark body, a chilled skin of cool, dark rock probably formed on the surface and insulated it and kept it warm for millions of years before it finally solidified. Now, the moon was gone through various epochs of time, much like the Earth. Now, back when we were young and we were fascinated with dinosaurs, we all knew about, the Jurassic and the Triassic and the Cretaceous era and all those fancy sounding names. Well, the moon went through similar periods of geologic time. Predictarian, about 3.9 billion years ago, back to the formation of the moon. Now, at 3.9 billion years ago was the initiation of the Nectarian epoch. This coincided with the late heavy bombardment, where the alignment of Jupiter and Saturn flung thousands of comets and asteroids into the inner solar system. Earth, Venus, Mercury, Mars, the moon, all heavily bombarded. Today, we still see that bombardment on Mercury, We see it in radar images of Venus. We see it on Mars. We see it on the moon, but not on the Earth. The Earth evolved an atmosphere and oceans and plate tectonics and erased this heavy bombardment, record of heavy bombardment. But we can look up at the moon and see what the Earth looked like almost 4 billion years ago. And then 1.1 to 3.8 billion years ago, the Imbrium epoch, where Mare formation took place. Volcanic eruptions flooded the lower lying basins created by the late heavy bombardment. The Eratosthenian epoch followed from about 3 to 1 billion years ago, and this is where much of the post-Mare formation cratering took place. And now we are in the current epoch on the moon, the Copernican epoch, from about 1 billion years ago to the present time. Any feature on the moon that is Copernican can be identified as an impact. The impact feature is identified because they will have a splash of crater rays spread out from, like Tycho, Copernicus, Kepler crater. Any crater older than about 1 billion years, the effects of space weathering, which are the continuous rain of micrometeorites churning and tilling the lunar soil, or eruptions from the sun causing changes on the face of the moon, will eventually erase these ray structures. So if a crater has a ray on it, it is Copernican, less than 1 billion years old. Oops, wrong direction. So going back in time, back to the Nectarian epoch, right after the late heavy bombardment, the moon looked very much different than it did now. It had a solid crust. The crater formation rate was perhaps 300 times as much as the modern era. The basins had formed, but there had not yet been filled with lavas to form the Maria. Then we entered the Imbrium epoch, lasted almost 1 billion years. Extensive volcanism flooded the low-lying basins and created what appears to be the caricature of the face of the man on the moon that we see today. And then during the Copernican epoch, the craters that have rays were formed during this era and gave the moon a bit of a personality. So it boils down that there are two primary landscape forming processes on the moon, either impact cratering or subsequent modification by volcanism. The Maria, the dark regions that form the face of the man on the moon, are volcanic. They're basalt. They have relatively few craters on them because they're older. Anything after that is younger and it occurred during a period of reduced meteoric impact, fairly flat. Now the highlands, the bright areas, this is the original crust of the moon. Is heavily cratered and fairly rough. So the first feature that we do notice on the moon, we can see with the naked eye, watching the full moon rise. These are the Maria, or the lunar seas, the dark basalt fields that have been deposited by ancient volcanism. The basins on the moon and the Maria lying within them are not the same thing. The basins were created by an asteroid impact. The Maria were formed by lava eruptions. So they are located in the same region, but they are two different features. A basin and a Maria are not the same item. And not all basins contain a Maria. There are 70 some odd basins on the moon, and the ones on the far side where the crust is thicker, there are no lunar Maria on the far side like there are on the near side. So the Maria define the face of the moon and create the caricature of the man on the moon. Now, 11 of these Maria were named by Giovanni Riccioli, an Italian Jesuit monk back in the 17th century. 8 more were named in the 19th and early 20th centuries, and then 2 were named during our lifetimes, during the space age. So the moon's face is not necessarily a static historical place. It is an ongoing, the map is changing even as we live today. Now, the common theme with the lunar maria is they are circular. Here we see Mare Nectaris, one of the earliest basins formed on the moon, and thus the name for the Nectarian epoch, period of about 100 million years, where we think most of the major basins on the moon were formed during the late heavy bombardment. Mare Crisium, also round. Mare Serenitatis, round again. These are circular impact basins, which are basically giant craters that flooded with lava and are now smoothed over. Mare Imbrium, the largest of the circular mare on the moon, appears as the man in the moon's left eye. Visually appears as the largest mare on the moon, but it is not. It is the second largest. Procellarum is the largest, but it is so foreshortened, as we will see in a moment, that it does not look that big. Mare Humorum, again, a circular impact basin flooded with lava. And then I said Oceanus Procellarum, actually twice as big land-wise, area-wise, as Imbrium, but it lies on the far western limb of the moon. And even though it's the largest of the lunar seas, it doesn't contribute anything to the caricature of the face of the man on the moon. It's just so foreshortened that we really don't see it that well. Now, not all lunar basins completely filled with lava. In the case of Mare Austral down in the lower southeastern quadrant of the moon, this is very near the far side of the moon, which has a thicker crust. So Austral formed in an area that has a thicker crust, which pinched off many of the lava flows that welled up. So Austral appears as a collection of lava flooded craters instead of a completely smoothed over parking lot like smooth Maria. And then again, some Maria don't lie within a single basin. Mare Frigoris, which arcs over the northern part of the moon, kind of forms the man in the moon's eyebrows. It's 1,800 kilometers wide, but it's only 200 kilometers high. And it may lie in portions of the pre-existing Procellarum basin, the Imbrium basin that overlaid it, and then the Serenitatis basin. Now, mountains on the moon are created by an entirely different process than those on Earth. Earth's mountains are continuously created by plate tectonics and volcanism and are eroded by Earth's weather and oceans and subduction into the Earth's crust by plate tectonics. Now, lunar mountains were created by an entirely different process, the impact of an asteroid. Lunar mountain chains are the raised rims of impact basins, but there are also individual peaks that form at the center of large craters because of the dynamics of how an asteroid impact rebounds on the moon and will create a central peak within a large crater. Now, lunar mountains have been unchanged since their formation literally billions of years ago, but Earth's mountains can be significantly altered in as little as 100 million years. So Earth's mountains are always changing. The moon's mountains are there forever. Now, taking a quick tour of some of them, the popular ones, the Alps Mountains. Lunar mountains are named after terrestrial mountain chains. The Alps Mountains extend eastward from the very well-known landmark of Plato, Plato crater, and they're bisected by the feature known as the Alpine Valley. Continuing down around the eastern side of Mare Imbrium, another portion of the rim forms the Caucasus Mountains. Going further south, the lengthy chain of the Apennine Mountains. And then as we get to the southern part of Mare Imbrium, the Carpathian Mountains, just north of Copernicus crater. Now, the western side of Mare Imbrium has no mountain chains. It is the rim of the Imbrium Basin impact ring in this area is completely submerged under the lava flows that formed Oceanus Procellarum. Now, not all lunar mountains are visible all the time. Take in case the Cordillera Mountains, which are the outer impact rings surrounding the Oriental Basin on the western limb of the moon. Now, this area of the moon doesn't get sunlight until just before full moon. But at full moon, there are no shadows. The high overhead sun eliminates shadows and you can't see details. So the Cordillera are visible for one day before full moon when they do cast a shadow, and we can see their ridge formed by the shadow behind them. And then the next day, and after that, the high sun hides these shadows, and we can no longer easily spot the Cordillera. So these mountains around the Oriental Basin play peekaboo with us. We only see them about one day per month. And other mountain rims or mountain ranges are the rim of Sinus Iridum, the Bay of Rainbows up on northwestern Mare Imbrium. The rim of this forms what we call the Jura Mountains. And then not all mountain chains on the moon have a name. The very prominent western rim of Mare Crisium is unnamed. There's an enormous amount of features on the moon that do not have a popular name. Now, getting into we've been talking about the bumps on the moon. Now let's talk about the holes, the different types of craters on the moon. And you may see some cat ears poking up if you're also seeing a picture of me. Yeah, I got a kitty on my lap. They always like to visit me while I'm doing a presentation. Different types of craters on the moon. Now, we classify craters three different ways. We call it the crater main sequence, a name borrowed from stellar classifications. The Hertzsprung-Russell diagram. Well, on the moon, we've got craters that are less than 16 to 21 kilometers in diameter. The dynamics of the impact that formed them will make a simple bowl-shaped crater. If the crater is larger than 16 to 21 kilometers, the impact dynamics will create what we call a complex crater, which has a central peak and terraced collapsed walls that tumble down into the interior of the crater. A crater classification that if it's above 300 kilometers in diameter, this used to be called a basin. Nowadays, we're beginning to realize that there are some basins that are smaller than 300 kilometers. So basins are also now defined by gravity anomalies on the moon that have been charted by orbiting spacecraft. So there are some basins on the moon that are smaller than 300 kilometers, but if the crater is bigger than 300 kilometers, it's automatically a basin. Now, here's some examples. Helicon and Leverrier up on Mare Imbrium, simple bowl-shaped craters. A complex crater, a very famous example, Copernicus. And then a basin, Bailey, which for years, centuries, was classified as a crater, but now we know is actually a basin because of its size. Now, complex craters, they feature a central peak and collapsed terraced walls. Now, these walls, when the crater forms, the walls don't have enough physical strength to maintain sheer cliffs, and they start to crumble and collapse and fall by gravity and crumble down into the interior of the crater by gravity, forming this bunches of these terraces, benches and terraces. Now, crater rays, I'm talking about the craters that are less than 1 billion years old. They're composed of pulverized glassy material thrown out from the crater by the impact explosion that created the crater. Now, these crater rays fade after about 1 billion years, and they are an indication that the parent crater is fairly young. Now, crater rays are brightest near the full moon. The glassy material thrown out by the impact explosion is very similar to the material that is on interstate highway signs that reflects back at you, catches your car headlights at an extreme distance and lets you read that sign, because the iridescence of the reflected material, you can see the sign long before your car headlights actually illuminates the sign. The same with crater rays. So they're brightest at full moon when this material is reflecting the light directly back toward its source, the sun. And of course, at full moon, the Earth is between the Earth and the sun, so we intersect those bright beams. Now, the Tycho ray system is the largest on the moon, spanning about 2,200 kilometers. Now, there's a mystery. Notice the feature extending upward to the northwest. We call it the railroad tracks, the parallel ray structure. And there's also that rogue ray extending south these are not aligned with the center of Tycho. All other rays align with the center of the crater that formed them, but these do not. If you can figure out why, you've got your name on a research paper. Now, there's other types of rays, the monodirectional rays, like those extending from Messier and Messier A, and the butterfly ray pattern, like that extending from Proclus on the right-hand side, are an indication of an oblique impact. In this case, a very low, very shallow, less than 5 degrees inclination impact. When this happens, no ray material will scatter back in the direction that the impactor came from. And in the case of Messier and Messier A, it was an even lower impact, and it showered out the rays in a monodirectional, almost search-like pattern. Whoops, wrong direction. Now, secondary craters are a different kind of crater created by the impact of ejecta thrown from a primary crater's formation, explosive formation. Materials blown out from a crater, showers out across the moon, impacts the moon, and creates additional craters. Now, these secondary craters, they're called, are very shallow because the impact speed cannot exceed the 2.4 kilometer escape velocity of the moon. If something is ejected from the primary explosion faster than that, it goes into solar orbit. So we think that a lot of craters under 20 kilometers in diameter on the moon are secondaries, but they can occur hundreds of kilometers from a primary impact. So it's sometimes hard to associate a secondary with its parent. Now, at this point, I'm going to call an intermission because I had dinner a while ago with a rather large drink, and I have to take care of something. So I will be back in about 30 seconds.
These images are beautiful.
Yes.
They are just unreal.
Often when I see Robert Reeves's images, it looks like, it looks like there's no atmospheric disturbance at all.
Yeah.
They look like they are 3D printed or something, and photographed from about 2 feet away. They
I
are
feel like I
amazing.
can reach out and touch, they're beautiful.
Yeah.
It's interesting, in spite of all the pollution and all, he can do that with filtering and all this right from his home. That's interesting.
Yeah, a lot of things have changed, since all of us got started in astronomy. I'm speaking on behalf of the people giving presentations here. Astronomers, amateur astronomers do more observations from home now. They're able to work around light pollution and other factors that might have bothered them before. No one has invented a cloud filter yet, though. No one's done that. And so if anyone in the audience has a idea of how we can make one, then you can make a lot of money. So
Yeah, definitely. Yeah, but it's amazing what he can do being that close to San Antonio. I mean, from
Right.
what he showed us at the beginning of the deep sky, it is amazing everything that he is able. But I love the
Oh
lunar
yeah.
image.
Oh yeah.
Well, sorry about that, but this sure brightens my attitude toward the second half of this presentation. Alrighty, pick it up. Um, Now, there's also elongated craters on the moon. They're not all round. We tend to think of craters as round holes in the ground. Not necessarily so. Heinzel is the result of multiple impacts, the overlapping of several actual round craters. The same with Rada E, the overlapping multiple impacts. But look at Schiller. That is one single oblique impact. Now, if Schiller's overall length were translated into the diameter of a circular crater, it would be one of the 10 largest craters on the moon. This is a considerable gouge on the moon. And continuing the theme that not all craters are round, Anaximander and Carpenter up at the upper left merge and form this very nice heart-shaped crater. Meton, lower left, my lunar good luck charm, a combination of 4 craters where very old ancient pre-Nectarian craters in the northern area of the moon that were subsequently, their interiors were buried by ejecta from the Imbrium Basin impact, obliterated the inner walls, merged them all together. So now we have this 4-leaf clover-shaped crater. And then here we've got Agrippa and Godin, kind of more or less bullet-shaped and bell-shaped. There's other craters that are distinctly pentagonal or octagonal. So not all craters on the moon are round. The chance merging of craters or the varying strength of the surface crust where the impact occurred can have a significant effect on the shape of a crater. Another class of craters is called floor fractured craters. And these are craters that started out as complex craters, had a central peak, collapsed terrace walls like we saw with Copernicus, but volcanic flooding welled up from underneath the crater, uplifted the surface, sometimes flooding the interior of the crater with basalt. This lava flooding didn't spill over the walls of the crater from the outside. It flowed up from below and welled up through fractures in the crust underneath the crater. And then the basalt cooled, subsided, cracked, created a series of rills, cracks. The overlying theme of a floor fractured crater is that it does have a series of rills and cracks across the floor. Makes it look very much like something out of an old Chesley Bonestell painting of the moon back in the 1950s. Yet another classification of craters are ghost craters. Now, these are craters that formed almost 4 billion years ago and were subsequently buried by the lava flooding that created the Maria between 4 and 3 billion years ago. Good example, Lamont, just north of the Apollo 11 landing site. We actually think Lamont now is a buried ghost basin because we can clearly see it is a double impact ring system that has been flooded with lava. Stadius, the upper right, you can see the circular rim of it, but it's been overlain by the ejecta from Copernicus crater. So it kind of obscures it. Another very famous ghost crater, Flamsteed P, also called the Flamsteed Ring. This was the landing area of Surveyor 1, America's very first successful robotic soft landing on the moon back in 1966. Yet another classification of craters is what we call a catena, a crater chain. And we had our friend David Levy on earlier. He is very well known for being one of the co-discoverers of Shoemaker-Levy 9 that slammed into Jupiter back in the 1990s. And we remember what happened there, where chunks of the comet rained down in sequence, like just continuously bomb the planet again and again and again. Well, this is what happened when we create a catena on the moon. Back early in the moon's history, rubble pile asteroids or comets got too close to the Earth-Moon system. The gravity broke them up into a string of pearls, and they rained down onto the lunar surface and created a linear chain of craters. Catena Mueller, Catena Davy, Catena Abulfeda make very famous examples. Another classification of feature on the moon, we were talking about features on the moon can be either a result of an impact or the result of volcanic modification. Now we see wrinkle ridges, which are a volcanic feature. These are known by the scientific name of dorsa or dorsum, dorsum singular, dorsa plural. And these are created with sheets of basalt on a basin slump and crush together as they slide toward the center of the basin. As the basalt fills the basin, its weight crushes down and depresses the center of the basin. The basalts on the edge try to flow toward it and sometimes buckle up into ridges. Wrinkle ridges can also form where it is flowing over the buried basin impact ring. Wrinkle ridges are typically named after famous Earth scientists. And in the case of the most famous wrinkle ridge, the Serpentine Ridge on eastern Mare Serenitatis, this is a combination of Dorsa Smirnov on the north, intertwining with Dorsa Lister on the south. These wrinkle ridges that can be hundreds of kilometers long, 5 to 10 kilometers wide, but they are rarely more than about 300 kilometers high. They're very shallow. You only see them at sunrise or sunset when they can cast a shadow. At higher sun elevations, they will disappear. Other wrinkle ridges, Dorsum Heim lies off the western shore of Mare Imbrium, and we see these unnamed wrinkle ridges. They look like frozen ocean waves washing into the Horseshoe Bay of Sinus Iridum. I mentioned some features on the moon are unnamed, even though they're very prominent. These unnamed wrinkle ridges arc around eastern Mare Humorum. Jumping up to a different kind of volcanic feature, rills on the moon are scientifically known as rima or rimae in the plural, and these are grooves and channels on the moon that are appreciably longer than they are wide. Now, these are formed by 3 different processes, all volcanic, but 3 different types of process. Now, straight rills are formed by the slumping of land between 2 parallel faults. This is called, on the Earth, it's called a graben. In this case, the crust is split apart by a volcanic dike, or a vertical sheet of magma that pushed up from the moon's molten core, but did not breach the surface as a volcanic eruption. Instead, it just split the surface, the land collapsed, and we now see it as these straight lines like Rama Hesiodus, or the rather lengthy Ramus Ursalis on the right. This extends for almost 400 kilometers, and you can see it extends across pre-existing craters. Arcuate or curved rills are created by stretching of the land near the shoreline of a maria. I mentioned that wrinkle ridges are formed by the basalt slumping and sliding toward the center of the basin. Well, as that moves toward the center, it stretches the land near the shoreline and pulls it apart and creates these curved rills. And then the third kind, the sinuous rills, are formed by flowing streams of lava, much like channels are cut in the earth by flowing water. Flowing molten lava will also erode a stream or a channel on the moon. In this case, Rima Hadley, the Apollo 15 landing site. Dave Scott and Jim Irwin explored this region back in 1971. Scarps on the moon are known by the scientific name of rupas, and they're formed by two different processes. Some scarps are the surviving rim of an impact basin, as in this case, Rupus altai being the only surviving chunk of the outer Nectaris basin impact ring. And other scarps are formed by land slumping on one side of a fault, such as Rupus cauchy, the bottom of these two. On top is Rima cauchy, a rill, and the bottom one is Rupus cauchy, a slope or a cliff. Of course, the most famous one, Rupus rectum, straight wall. This quickly becomes one of the lunar observers' favorite. And it extends for about 100 kilometers, descends about 400 meters in height. Past volcanic on the moon is evident in the form of pyroclastic deposits, sinuous rills, ash deposits around cinder cones, and volcanic domes. One of the more prominent features, the Aristarchus Plateau up on northern Oceanus Procellarum, volcanically built up region, roughly rectangular in shape, highlighted by the recent formation of Aristarchus crater on the southeastern corner, and of course Schroeder's Valley, one of the largest volcanic rills on the moon, running right through the middle of it. This heart-shaped pyroclastic region, very near the center of the moon's visible disk, darkened by pyroclastic deposits thrown out by volcanic vents along Rima Hyginus. Around the inner circumference of the walls of Alphonsus crater, we can see dark spots about the 9 o'clock, 3 o'clock, about the 5 o'clock region. These are volcanic cinder cones where once volcanic ash blew out and settled down and darkened the territory around it. And of course, I'm going the wrong way, aren't I? Now, volcanic domes on the moon are bubble-like swellings or small shield volcanoes where highly fluid lavas formed low pancake-shaped structures. There's no volcanoes on the moon that are steep-sided cones like Vesuvius on Earth. They're fairly low pancake-shaped structures. The Marias Hills being a collection of the most famous ones. Mons Rumker up on northern Procellarum, another example. So, to get close to the end of this, we'll take a look at some sentimental lunar favorites, regions of the moon where no matter if you're a novice or you're an experienced observer, you're always going to come back to these regions because they are so unique. They just catch your heart. Plato crater, of course, is a favorite because it just doesn't look like a normal crater. It's completely lava-filled, paved over inside, flatter in a parking lot. Just doesn't look like a normal crater, so it immediately gets your attention. No, it's on north shore of Mare Imbrium, Mare Frigoris just above it, Snake-eyed Cassini down to the southeast of it. Remember I said not all craters are round? Look at W Bond. It's square. And getting closer to Cassini, closer to Plato, it is nested in the Alps Mountains, and the Alpine Valley is just to the east of it, another spectacular landmark that is everybody's favorites. South of Plato, there's these little isolated mountain peaks, Pico and Python, protruding from the basalts of Mare Imbrium. People love these little regions. I'm not exactly sure why, but they have a place in my heart as well. Just isolated little peaks in the middle of nowhere, yet we tend to love them. And then, of course, whoops, wrong direction. The there's a feature that I call Thor's hammer. Looks like Mjolnir, the Norse god's hammer that Agent Coulson has been looking for so long, and it's been laying right in plain sight all along. Closer yet to Plato, once you see the little craterlets on the floor of Plato, you've got some pretty good seeing going that night. They're very small, less than 3-4 miles in diameter. So if you're picking those, excuse me, you're picking those up in your telescope, you got some pretty good seeing. Tycho crater is another favorite. You can see where Tycho is with the naked eye, just looking at the full moon. The ray structure points like an arrow to where Tycho is, but unfortunately Tycho's too small to be seen with the naked eye. But with a telescope or binoculars, it shows up real well. Now, Tycho is very young, only 1.8 million years old, and laying in the midst of all these old fellows that have been around for 4 billion years. So Tycho is about 40 times younger than the craters in its immediate surrounding. Close up on Tycho, here we see the territory. Whoops, didn't mean to advance. The territory around it is very heavily pitted. Look at the thousands of tiny pits. These were created by the secondary. These are secondary craters created by the material blasted out of Tycho by its explosive formation, showered down and created all of these hundreds and hundreds of fresh secondary craters all around Tycho. And here we can see even closer up all the thousands of pits in the territory created by the shower debris thrown out from Tycho. Copernicus crater, near the equator of the moon, another very well-known feature that becomes a sentimental lunar favorite. Very pronounced ray system at full moon, but also a spectacular feature at sunrise. It's just south of Mare Imbrium. Eratosthenes crater up above it, the Carpathian Mountains just north of it, a spray of secondary craters thrown out from Copernicus. Mare Insularum, one of the new seas on the moon, named just as recently as 1976, the Sea of Islands, so named because the thousands of peaks protruding up through the Mare surface look like islands. And then, whoops, wrong direction. And then just to artistically balance the picture, nature threw Reinhold crater in there. The straight wall, a non-crater feature that becomes a sentimental lunar favorite. The feature at sunrise casts a shadow, so it's a black line feature. At sunset, it will cast a it will be fully illuminated and be a white line feature. It's on the western shore of Mare Nubium and just south of our Zatchel crater. Thabit crater is lying just east of it, and because of its presence, we call the horseshoe bay that is enclosing straight wall and the wrinkle ridges on the western side of it, denoting the buried crater walls that continue on from this horseshoe bay. Well, that is unofficially known as ancient Thabit. And a look at straight wall at sunset. It's just about to fade into sunset. Now imagine standing on the top of straight wall, looking down on the plains of Mare Nubium in front of you, looking toward the sun. On Earth, the sun goes down, it'll just touch the horizon, the ball of the sun will slide below the horizon and disappear. It takes about 2 minutes. Remember, the moon rotates much more slowly. Sunset on the moon will last an hour. That's an awful long time to sit there and meditate about the beauty of the universe and come up with all kinds of poetic things in your mind. Now, concluding this presentation, we'll go through a series of nicknamed features on the moon. And just like on in the sky, we've got all these various deep sky features that we know by nicknames: the Swan Nebula, the Omega Nebula, the North American Nebula. These are unofficial names, but everybody knows what they are. Well, there's similar features on the moon. My lunar good luck charm, Meton crater, the combined form of 4 separate craters that now form the good luck charm, lunar good luck charm, 4-leaf clover. Chuck Wood named these features the large massifs that rise at the entrance to the Alpine Valley, where the Alpine Valley spills out into Mare Imbrium. He calls these the guardians. I mentioned Thor's hammer before. So you're looking south of Pico and Python, keep an eye out for Thor's hammer. It's very distinctive. The Valentine Dome, a larger than normal volcanic pancake dome on the moon. It looks more like a pancake to me, but for some reason it's taken on the name of Valentine, because somebody thought it looked like a Valentine, but I'm not quite picking that up. Cobra Head, the volcanic pit at the head of Schroeder's Valley. Billions of years ago, this fed molten lava into Schroeder's Valley, and it spilled out onto Oceanus Procellarum, and pyroclastic explosions and fire fountains would spray out of this and dust down the whole Alpine Valley with volcanic ash. The heart of the moon, the mountainous region just north of Ramah Hyginus. The volcanic vents on Hyginus showered this whole area with dark volcanic ash, making it appear darker than the surrounding territory. And since it is heart-shaped, I call it the heart of the moon. The lunar spider, the ghost crater Lamont that I mentioned earlier, has radial ridges extending north and south, giving it a very spider-like appearance. And the ghosts of Procellarum. These are unnamed and some named ghost craters protruding, their rims protruding up above southern Oceanus Procellarum. And there are many of them in this territory. So collectively, I'll call them the ghosts of Procellarum. And then I mentioned ancient Thabit, the Horseshoe Bay and Wrinkle Ridges denoting the western part of the ancient crater that has been flooded with lava from Nubium and creating the Horseshoe Bay, and finally the volcanic event that created the Straight Wall. And the railroad tracks again. The parallel rays extending northwest from Tycho crater that do not converge at the center of Tycho. So, in concluding, I'd like to say the moon is ever-changing. It's not just the same static thing in the sky every night. Its phases grow and shrink day by day. The shadows change hour by hour. The moon is a geologic wonderland if you know what to look for. And I hope I've shown you enough that you can recognize some of these features now. And when you look at the moon, the moon is a little bit more friendly with you because you understand it a little better. And most of all, the moon is accessible from your own backyard. The moon does not care about light pollution. You can see the moon anytime. So you don't need to go out of town. You don't need a large, huge telescope. You don't need dark skies. The moon is your companion anytime you want to go out and look. So there's much to love on the moon, and I invite you to come out and join me on my playground. So appreciate your attention. Thank you very much.
Wow. Thank you, Robert. That was amazing. I mean, the images, everything that you brought up was just amazing. I have never heard of Thor's hammer. And to see that, I mean, it's things like that that just get my imagination going, you know.
Yeah, well,
and you took all of those pictures,
yes,
correct?
yeah, they're all mine. All taken from
Okay.
out in my backyard.
So did you use an 8-inch to do all of those, or did
No, I used an 8-inch C8. I used a 180 millimeter Maksudov. I used a Celestron 11, and some of them were taken with a 20-inch Stargate. People
wow.
think that an F4 Dobsonian is not a good lunar imaging device, but it worked real well for me.
Yeah. I am curious, and I know if there's other questions, Scott, you can stop
Yeah.
me at any time. I am curious. The Cantina Davy, the chain of craters, the
Yeah,
crater chain.
yep.
What size telescope would you need to see that?
It's fairly easily accessible with oh heck, a 4-inch refractor will see it. Anything above that, all of these features that I was talking about, you can see with almost all backyard telescopes. If you have a C6, C8. You're in good shape. You don't
Okay.
need monstrous telescopes to see these. I found that, as per my introduction, that excessively large telescopes are a detriment in poor seeing. And in South Texas, my seeing is not the best. The
Yeah.
moon ripples and dances and does bad things. And some nights I just have to give up and try again later.
Sure, sure. And I am curious, Tycho's ray system, does it go clear across the front of the moon?
Pretty much, it spans about 2,200 kilometers. It goes to the west, not as far as it spreads to the east. The Tychonian impact the impactor arrived from the west, so much of the splatter went to the east. But
Okay.
yeah, it spreads pretty much across the entire southern hemisphere of the moon.
That is amazing. Okay, so Thor's hammer. I've got to see this. I'm going to work on that one. That has just mystified me. And the crater chain. Both of those really caught my attention. I like you said, the craters are amazing. But when you get and you see little shapes and little things like that, just kind of really pique your interest as
Well,
to
like I
what you
said,
can actually see.
it gives the moon a personality.
It
Like I
does.
said, it's not just bumps and holes. Each
Yeah.
crater has a story to tell. Each crater is different. Each crater is unique, and how they interact with each other tells a story too. So there's a lot to poke around and understand on the face of the moon. It's uh, like I said, it's just not this static thing that's the same night after night. Um, Become friends with it, and
Yeah.
it will grow a personality that you will appreciate.
Yeah, well, thank you for bringing that to us. You brought us something all new. I'm amazed. Those were beautiful images, just beautiful. So I will be quiet now and let somebody else talk.
Yeah.
There is just one question here from Off-Road who's watching on YouTube.
Okay.
He wants to know what method is used to roughly date the known craters.
Okay. There's a technique called crater counting, and the more craters there are in a given area, um, the older it is. And uh, there's what they call the law of I can't pronounce it. Yeah, basically it's the stacking of things on top of each other. The topmost is the youngest, of course. What's on the bottom is the oldest. And all of this was kind of guesswork until we went to the moon, got samples from certain areas of the moon. We've retrieved samples from very limited portions on the moon. The 6 Apollo missions, 3 Russian Luna missions, now a Chinese sample return. So we have very limited amount of sampling of specific parts of the moon, but from those areas, we can get geologic dating with samples in hand. Compare that to the region that they came from. We can date that particular region. We can compare that region to similar appearing regions and begin to deduce some rough general ideas of when they occurred. Um, whether or not an object appeared or was formed like in the early Imbrium or the late Imbrium or the early Eratosthenian, late, that's kind of hard to pin down. But on a gross scale, they can figure if a crater occurred before about 3.9 billion years ago, pre-Nectarian, if it occurred during the late heavy bombardment, with a very narrow period, only about 100 million years, or during the Eratosthenian epoch, which is about 2 billion. Of course, if it has crater rays, we know it's Copernican. It's probably a billion years or less. So there's various techniques for dating things on the moon. It's not a precise science, but we can get generalized ideas about the ages of a lot of things.
Excellent.
Robert, Carol Orge here. I have a question.
Sure.
You do wonderful work there in the middle of the city. It's most impressive. My question is, as you know, Starlink is coming along. At some point, there's estimated to be 40,000 or so going to be out there. Do you see that impacting your work at all?
Yes,
sounds like there's
I
been
have.
workarounds with other things.
Yes, I see them trickle through my pictures sometimes. I call them something else that also begins with an S, but fortunately there are image processing techniques that of course the word just vanishes out of my head right now. Oh my gosh. Okay, senior moment. But there's image processing techniques that will eliminate something that occurs in one frame but does not occur in the others. There's a term for it, and I forgot what it is, but it's a very common image processing technique. So we can take care of this and make satellite trails go away, but they are kind of a pain in the rump.
Yeah, I figured you had some kind of a workaround, given the workarounds you've worked with, being able to get those beautiful images.
Occasionally
there's some masking techniques that are coming out in the professional community that will probably trickle down to the amateur community very soon.
Oh, there already is. I'm shocked that I forgot what this is called because I use it every time I do a deep sky image. It's part of the process of select a process you can select in Deep Sky Stacker. They're very popular freeware for assembling these things. And occasionally, just for fun, I'll process an image without that option, and it's just zigzagged with satellites, airplanes. I live not far from the international airport here in San Antonio, so I get airplanes through, and so I'll let the image process with those in it just to see how bad it is, and then I'll go back and I'll invoke the thing that makes it go away, and poof, they're all gone. So we can eliminate it, but yes, it is a pain in the butt.
Good. Glad there's a workaround.
Oh yeah, we've got it in place already.
Yeah.
We have another question here from Andrew Corkill watching on YouTube. He said, you talked about using the small craters within the Plato crater to test seeing. Are there any other popular seeing tests on the moon?
Yeah, the Alpine Valley, just east of Plato. If you can see the central rill meandering down the middle of the Alpine Valley, rejoice, you have an extraordinary night going. That feature is only about half a kilometer wide, but it runs the length of the valley, which is about 100 kilometers long. Now, ordinarily, you don't see detail that small on the moon. An individual crater half a kilometer in diameter, no, it is gone. You're not going to see it. But linear features, very thin linear features, will show up. And it's the same way when you look off in the distance, you can see telephone wires stretched between power poles. But if you're trying to find, I mean, those wires are what, like a quarter-inch in diameter at best. Mm-hmm. But if you're trying to see a quarter-inch diameter singular feature at the same distance, you will never see it. Because it is a linear feature, you can see it. So features like that show up on the moon, even though they're very tiny. Other things, if you just know where to look, secondary craters that are particularly small. After you poke around the moon long enough, you begin to know the topography a little bit. But the secondary, little secondaries inside of Plato, the central rill, down Alpine Valley. Those are probably the most famous ones for checking out whether or not you can have bragging rights that night.
All right. And then there's a request to share some lunar eclipse photos. Maybe that's something for next time. But do you like to photograph the lunar eclipses?
I do, but I don't do a very good job. I have to admit, when I do, it's a quick and dirty deal, so I can get a picture for the newspaper column that I write. I've really, I enjoy looking at them, but
Sure.
I've never really hammered down to do really good, uh, 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 high depth, uh, colorful uh, uh, eclipse photography. It's been a grab shot, so I can put it in my newspaper column.
Hmm. Excellent.
Well, thank you again. That was an amazing talk. I
Well,
really enjoyed that, as I'm sure everybody else has too.
Well, I do deeply appreciate the opportunity to give it in light of my inability to do it in person in Baton Rouge. Uh, I couldn't help the circumstances, but it still broke my heart that I couldn't be there. So I'm very grateful to have been able to do this after all.
So are we. Yeah, that was amazing. So thank you very much. Um, Please join us in October, on October 27th, for our Halloween party. We do a party every year. Please join us. I will get all the speakers listed as soon as I get everybody rounded up, and we'll announce that. And thank you again, Robert. The amazing talk. And Carol, thank you. Scott, thank you. And I think I will turn it over to you. And thank you, everybody out there watching too.
All right. That's
Bye
great.
bye. Good to be here.
Thank you.
See
Thanks
you
a
later.
lot. Okay, so you've seen another great episode of Astronomical League Live. It comes on every month, usually on a Friday, and we'll be announcing the next one pretty soon. So until that time, keep doing what our friend Jack Horkheimer always used to say, and that is to keep looking up. Hope you guys have clear and steady skies this weekend. And until next Tuesday, when we do the Global Star Party, which will also feature the Astronomical League, we'll see you then. The theme for the Global Star Party, which is our 132nd, will be asteroids unveiled, and the host will not be me; it will be Pranvera Hysini. So really happy to do that, and she's got some special guests that will be on. So take care and enjoy, and wishing you all well.